Okay, I'm going to do the logs, solving inequality logs. So it's very similar to solving equalities, except for we have a rule that says that we can't have a negative value. You can't do the log of a negative value, okay? So let's say that I have something like this. I'm going to solve it out. So in order to get rid of this log, I'm going to do 10 to the power of. Those cancel out. I'm left with 2x minus 17. Whatever I do to one side, I do to the other. So I get this. 10 to the power of 3 is 1,000. Now I'm going to add the 17. So I get 2x is less than 1,017. And then divide by 2. X is less than 1,017 over 2. So this is part of my answer. But I also know that I can't have this as a negative. So whatever is my log is going to be greater than or equal to 0. It can be 0, but it has to be greater than or equal to that. And then we're going to solve this out. So we're going to add 17. We get 2x is greater than or equal to 17. Divide by 2, and x is greater than or equal to 17 over 2. So it's greater than or equal to this and less than this. So we would put it like 17 over 2, and then 1,017 over 2 not included. Okay, this one's included, this one's not. So really what you're looking at is you just want to make sure that whatever you're doing the log of is greater than or equal to 0, and then solve the rest of it normally. Now sometimes your answer will already include the value that would give you greater than or equal to 0. Let's say I have something like 2 minus the log of 3x is greater than or equal to the log of x over 12. In order to get this, I want to get both my logs on the same side, so I'm going to add this over. So I have 2 is greater than or equal to the log of x over 12 plus the log of 3x. Because they have the same base and they're adding, I can turn it into one log, which is going to be the log of x over 12 times 3x. Now, I can get rid of this log by putting it as 10 to the power of. Whatever I do to one side, I do to the other. So I get 100 is greater than or equal to, and I'm just going to multiply this together. That's going to give me 3x squared over 12, which is really x squared over 4. Now I want to get the x by itself, so I'm going to multiply both sides by 4, which gives me 400 is greater than or equal to x squared, and then I'm going to do the square root of both sides, and I get 20 is greater than or equal to x. Because I did the square root, I really should also say that negative 20 is greater than or equal to x, right? When I do this, I need to check my values. If I plug them into my original equation, does it give me a negative value for the log? And this one does, so I'm just going to cancel that one out. X is less than or equal to 20. And then remember, I have to say this is greater than or equal to 0. And I'm going to have to do it for both of them. This gives me x is greater than or equal to 0. And this gives me x is greater than or equal to 0. So x has to be greater than or equal to 0 and less than or equal to 20. Okay, that wasn't the example I was looking for. That's okay. It's going to be greater than or equal to 0 and less than or equal to 20. Now let's say I did the exact same example. Let's say I did the exact same example, but this was originally a less than or equal to sign. Okay? So when I get to the end, I have x is greater than or equal to 20 and x is greater than or equal to 0. Well, when I say this, I've already said this. So I don't need to say them both. I would just put 20 to infinity, not included. Okay? So we're looking for our values, but sometimes when you're doing them, it's already included in the value. It's already stated that it's greater than 0 because I said it's greater than or equal to 20. And I hope that makes sense. So you just want to make sure that your logs aren't of negative values. You can't do a log of a negative value. That's undefined. So you want to make sure that that's not happening.